In this video, we'll go over a special case when the regressor is a dummy variable. A dummy variable is a categorical variable that takes on different discrete values. Frequently, dummy variables take on only two different values. For example, in the California schools example, we could dichotomize the str variable into two different scenarios. If str is smaller than 20, we call it small class. Otherwise, it's not a small class. If the small class dummy is true, that means small class times S dummy equals to 1. Otherwise, the small class dummy is equal to 0. In the wage example, if we want to explore whether gender plays a role in explaining the variation of wages, then we could create a gender dummy. In this case, we let female dummy equal to 1 if the gender of the worker is female. If the gender of the worker is male, then the female dummy is equal to 0. If your only regressor is a dummy variable, then the regression model can only be written as one of these two cases. If the dummy is true, or d equals to 1, then your outcome variable y is given by beta naught plus beta 1 times 1 plus u, or beta naught plus beta 1 plus u. If your dummy variable is not true, or d equals to 0, then your outcome variable y is simply given by beta 0, beta naught plus beta 1 times 0, and this term goes away, plus u. And this is equivalent to beta naught plus u. For the California schools example, if the small class dummy is true, then the test score is given by beta naught plus beta 1 plus u. If the small class dummy is not true, then test score is simply beta naught plus u. And in the wage example, similarly, if female dummy is true, that means the wage can be estimated using beta naught plus beta 1 plus u. And if the female dummy is not true, that means if it's a male worker, then the wage is given by beta naught plus u. Now, how do we interpret the meaning of the coefficient for the dummy variable? Previously, the regressor is assumed to be continuous, and hence the coefficient for the regressor is the slope of the best fitted line. When your only regressor is a dummy variable, this regressor is a discrete value. This regressor is a discrete variable, and hence we can no longer think of beta 1 at the slope of the line because there's no line. Recall that previously we talked about thinking of the regression model as a conditional expectation of y given x when the first least squares assumption holds. In this framework, the expected value of y given dummy is true can be estimated using beta naught plus beta 1, and the expected value of y given the dummy variable is not true is simply beta naught. Therefore, beta naught plus beta 1 is the population mean of y when dummy is true, and beta naught is the population mean of y when dummy is not true. The difference between these two population means is equal to beta 1. And hence you can think of beta 1 as the marginal impact of the dummy variable on the population mean when the dummy variable is true. Back to the California schools example, if the small class dummy is true, then the mean of the test score is 657.24. And when the small class dummy is not true, that means the class size is a large class size, then the population mean for the test score is 650. That means the difference in population means give us what is the estimate for beta 1 hat, or when the dummy variable is true. The difference is calculated using 657 minus 650, which gave us roughly 7.1. And the OLS estimate confirms this result. You see the estimated coefficient for small class dummy is equal to 7.1. This means on average, the small class size increased test score by 7.1 points. In the wage example, If the female dummy is true, that means if the gender of the worker is female, then the population mean, or in this case, the mean of wages is $4.58. When the gender of the worker is male, the average wage is $7.099. So that means the estimated beta 1 that corresponding to when female dummy is true should be 4.58 minus 7.09, which is roughly negative $2.5. Again, the OS estimates confirmed this result. So this estimate of negative $2.5 means if the gender of the worker is a female, then on average, they earn $2.5 less as compared to their male coworkers. This implies that there is a gender gap in wages between males and females. Now let's pause this video to take in-class exercise 9 through 14.